I think we've concluded, I believe that tranexamic acid is safe in head injury patients, that it reduces head injury deaths, but that the statistical teaching has damaged science because we have stopped thinking and it's much easier to dichotomize than to think. It's much easier to have a decision rule than to use our judgment.
I have a question.
Yeah.
So, when you wrote the statistical analysis, so did you describe the statistical significance in 5 p-value of 5% or 95% confidence interval in your sub? Or so
we did not mention p-values at all in the statistical analysis plan, apart from heterogeneity p-values. It's the only p-value that I find acceptable is a heterogeneity p-value. So we only talked about heterogeneity p-values. We didn't talk about p-values at all. So there's no mention of p-values in our statistical analysis plan. We said we would present relative risks and 95% confidence intervals. But that doesn't mean to say, we're not inviting you to turn it into a p-value. We're not, like when you have a confidence interval and you look at it and you say, aha, the upper bound of the p-value of the confidence interval includes 1. All you're doing in your head is you're turning a confidence interval which is telling you lots more information. You're turning it into a p-value. And you're doing the dichotomization of positive and negative, less than 0.05, more than 0.05. So in our statistical analysis plan, we didn't mention p-values, but we talked about 95% confidence intervals. Does that answer your question? Do you feel happier or or less happy or?
thank you. She has a question.
First of all, I like how you fiercely defend your data, because I work in immunology and genetics, and honestly, the last thing I look at is the p-value. I try to look at every single piece of my data before jumping to the conclusion, is it significant or not? But what if in the side effects, you notice that it is idiosyncrasy of tranexamic acid.
So what if, I couldn't hear that.
An idiosyncrasy to the tranexamic acid. And you are not supported by the p-value now. So would you, like, now the physician will be afraid my patient might die, but I have no parameter to estimate if it's going to that allergic reaction. But what if I am conducting a trial and I'm now in your position, but my drug is inexpensive but has a serious side effect? Should I go to the public and say, just give it a try, or should I just know it's a negative conclusion?
No, I think if you've got a side effects, if you've got a significant side, significant to the patient, not statistically significant, if you've got evidence of a side effect, then you have to start weighing off things. You have to say, on the one hand, I've got this potential benefit, on the other hand, I've got this risk. And then you have to make judgments about, the values of the risks of the different things and the utilities of the different things. But in this case,
Parameters you should suggest, like, because we invent the parameters and values, you help us judge. So now we are like given up on p-value. You suggest like relying on other parameters. Or just considering it if it's the only way to judge.
the American Statistical Association, I don't think they said stop using p-values, but they said stop dichotomizing on the basis of them, right? Because this p is less, stop saying that results are meaningful or not meaningful depending on this arbitrary value, this arbitrary dichotomization. That doesn't make any sense at all. The null hypothesis, the p-value is the probability that if the null hypothesis is true, that you'd get a result as extreme or more extreme as this by chance alone. Now where does, and that's a number that goes anything from 1 to 0, but where does this 5% come from? It's not helpful, I don't think. And so results should not be dichotomized into positive or negative. They should be seen within the broader context of what's gone before, other trials in the area, biological insight. It all has to be brought together. And so So I think statistical teaching, I think we have to learn to, we have to learn to embrace uncertainty. And we have to weigh off the different, we have to think, well, let's see, what are the consequences given the point estimate? What are the consequences given, sort of, a smaller treatment effect or a larger treatment effect? What are the implications? We have to make our judgments about that. But we have to make judgments. And I think dichotomization is a problem.
Yeah. It should be that the bad statistical teaching has damaged science.
Bad statistical teaching. Fair enough.
I have a question about
Yeah.
your interpretation.
Yeah.
Because the tranexamic acid reduces the mortality within 24 hours. And then it's effective to the mild to moderate TBI patients.
Yeah.
I think the mild to moderate patient will live long, not death within 24 hours.
Yeah. What?
Can I explain?
Okay. So what happens is that if you have a severe head injury, this is what I think is happening biologically. If you have a severe head injury, your bleeding in the brain can kill you on the day one. If you get tranexamic acid, it's less likely to kill you on day one. So you're more likely to survive. If you have a mild, moderate, or severe head injury, you're more likely to survive, to be alive to day 2 if you get tranexamic acid. But with any treatment, we only live to die from something else. No treatment reduces mortality. It only delays mortality because everybody dies in the end. So with tranexamic acid, you don't die on the first day. That's good. But you might die on the 2nd, 3rd, 4th, or 5th day. If you have a very severe head injury, you get a treatment benefit on the first day. You're more likely to survive the first day, but that doesn't necessarily mean you get out of hospital. There's a big effect on whether you get out of hospital alive. But if you have a mild or moderate head injury, if you don't die on the first day, you've got a really good chance because nothing else is going to kill you. So I feel biologically that tranexamic acid probably has the same effect in everybody. And for that reason, I would give it to everybody. Because getting a patient to survive the first day, why wouldn't I do that, I feel it's just, it's effective in everybody on the first day, but it's all diluted out. And it's, in high-income countries, you get that benefit from the first day, and it keeps the benefit because your chances of dying from something else are less. But in low-income countries, that if you have a severe head injury, you might get a treatment effect on the first day, but you're not going to get out of hospital alive because there are so many other things that are going to kill you. That's my interpretation of the results. But yeah, the lady at the back, I don't feel like I'm defending my data. I don't believe that it is a matter of defense. I'm trying to understand it. But if I really believed the treatment was absolutely useless or dangerous, that's what I would be telling you. I've got no stake in this treatment being effective or good.
But I saw so many good projects and papers just thrown out because they have no p-value.
Because they don't have a p-value that's less than 0.05.
Yeah, so I made the article since it's really amazing why it's thrown in that place because I think the author, I think the editor, I think the reviewer underestimated their work just because of the p-value. But I respect the data that it's giving. That's what I'm saying.
Well, I taught a course on research integrity here last year and the year before, and I met PhD students who were devastated that they didn't have what they believed statistically significant result in their PhD, because how and now are they going to get it published? And if they didn't feel they could get their PhD paper published, they were, they didn't think they would get their PhD. And they were searching around in their data for something that was significant at the 0.05 level. And it's really bad for science.
And that's what I'm saying, because they gave up. They didn't try to make their data meaningful, even if the other p-value is not supporting them.
Yeah, I think sometimes they imagine what editors think more than what editors really think. And they get this focus on a p-value, and that leads to this sort of p-hacking, where you're searching around for a significant for a less than 0.05, and then you exclude a few patients here and a few patients there, and you get the right result.
And sometimes I see the opposite. Sometimes you get the good data with the very significant p-value, but from a biological point of view, and make the context unfair.
Yeah, I think it degrades our thinking, and it's really bad for science, I think, that we dichotomize in this way. And that the editor of The Lancet does too, This is a neutral result, quite close to the magical number of 1. I mean, I don't know what they're talking about. But the good thing about the editor of The Lancet was that I spoke to him on the phone about it, and he was convinced. He changed his mind. So, I think it's good from that point of view.
Yeah. So may I ask how many rounds of exchanges you had with the editors at the Lancet?
Well, it was all going very well. They sent the paper out for peer review. The paper was accepted. And it was just at the copy editing stages where there was this interchange between two editors, copy editors, and one said, "Oh, should we say this because P is not more, the confidence interval includes 1. Should we say this?" And then the other editor said, "Maybe not." We'd said, tranexamic acid reduces head injury deaths. And so there were 3 rounds of proofs because we want to get it all correct. The first round, the second round. In the third round, they added a word. And it said, we'd written, tranexamic acid reduces head injury deaths. And they'd add this word, might. Tranexamic acid might reduce head injury deaths. It's like a tabun, I mean, we knew that before we did the trial. So, I felt I strongly objected to the inclusion of the word might, because I thought, well, crumbs, don't give me might. I knew that, but you could say that before we randomized 12,000 patients, that it might reduce head injury deaths.
But then did no reviewer point that out?
No, and I think it's a credit to them, because I think it's because they were more clinical, actually. that they actually saw the results more as in the gestalt, really. All right, you know, it reduces, you know, there's evidence of treatment effect in the mild to moderate, as we'd expect. We wouldn't expect much of a treatment effect in the severe head injuries because they have, you know, lot of intracranial bleeding at baseline. You know, you might say it's a subgroup analysis, our mild to moderate head injury, but it was a subgroup analysis that had, I don't know, 6,500 patients in. You know, it wasn't like, it wasn't a trivial subgroup analysis. So nobody objected, no. And the other thing I pointed out is the, that we ought to sort of look at the results in a more Bayesian way, really. That we ought to take into account what we already know about this treatment. And maybe the null hypothesis isn't the right reference point.
I think there you're going beyond the single trial, going into meta-analysis and evidence synthesis.
No, I don't think so. I think it's a sort of, you know, taking into account what we already know. You know, it's like what is your sort of, it's like having a prior, you know. Well, in tranexamic acid reduces bleeding in surgery. It reduces extracranial hemorrhage. Most of the treatment effect is on the first day. And then we find in head injury patients, tranexamic acid reduces bleeding on the reduces head injury death on the first day. Yeah, how do you put all of that together? You know, well, the p less than or more than 0.05 doesn't even come into it. You just, now you have to start thinking about, you know, biology, and that's, you know, that's what we should be thinking about, I think. Yeah.
I have a comment. In fact, the last time I listened to a seminar about the immunotherapy, that about the statistics, because they have they give a figure about the treatment and placebo. At the first 3 months, they coincide with each other, but from the 3rd month to the 9th month, the treatment showed a better effect. And after that, the two curves after 9 months, it almost stable like that. So they talk about the lag time, the delayed effect of the treatment. I'm just wonder that in this case, of course, how can I say, the improvement of the statistics should let us to find the truth as closely as possible. So in this case, I'm also wondering, how can I say, is there any delayed effect to the patient? For example, if this patient can survive until the 2nd day, maybe this treatment will show effect to those kind of patients. I was wondering about such kind of effect.
Yeah. I think with the cancer example, when there was no benefit and then it appeared later on, I think you just have to interpret clinical trial results in the light of what we know about the biology of the drug, you know, how it works. But in this case, I think living, you know, surviving the day of the injury, I don't know why we wouldn't offer that to a patient, you know. Even though they might only die from something else. I don't know why and that was all pre-specified in the statistical analysis plan. We said the effect of tranexamic acid is predominantly on bleeding deaths. The bleeding deaths are early deaths, so we're going to look at the effect of tranexamic acid on, this is our first secondary endpoint. We're going to look at the effect of tranexamic acid on deaths within the first 24 hours. And you know, exactly, you know, it was pre-specified. It was not, you know, speculative after the fact stuff. We found, you know, and so if you can get the patient through the first 24 hours, well, it sort of doesn't. This is what. So supposing the late deaths are from pneumonia, right? And we haven't got good treatments for pneumonia. So if the late deaths are for pneumonia, and the lack of an effective treatment for pneumonia seems to be affecting the efficacy of tranexamic acid. So it doesn't really make sense, does it? You know, that tranexamic acid is effective if we've got a good treatment for pneumonia, but not effective if we don't have a good treatment for pneumonia. I think you've got to isolate, you've got to go for the biological effect that you think's important. And like not dying on the first day of the injury is better than dying on the day of the injury, you know? And then we'll have to see, well, is there anything else we can do to stop them dying on the third and fourth and fifth and sixth day? But it's, you know, it's an interpretation. I think we, unless anybody, any more questions or comments or, yeah, please.
Thank you for this presentation. I'm a basically emergency physician,
Yeah.
so I understand the result.
Yeah.
I think it is very reasonable. So can I ask, so this, I think this primary analysis and the result means the tranexamic acid cannot reduce the mortality in all head injury, right? And it might reduce moderate to minor head injury. So you say so the result, so estimation is like a continuous variable, so it is not dichotomous. So I totally agree with it. However, the clinical trial is so answer the it cannot reduce all head injury. Is it correct? So I think.
Well, I think that's the question. I mean, that's the practical question is, who do you give it to? Do you give it to all head injuries as soon as possible, or do you only give it to the mild and moderate patients?
Usually, so I give all the patients.
Yeah, I would do the same, because I think it reduces the risk of dying on the day of the injury in everybody. But, and those are the oranges, right? There's a treatment effect on the first day, and that's probably for everybody. But it's if you have really bad head injury, you're going to die. You've got a really high chance of dying from something else. But still, it doesn't mean to say that this isn't worthwhile. You know, not dying on the day of the injury is good. You know, but you only live to die from something else, and that's bad. But you know, you would give the patient the mechanistic benefit that you feel. That's how I interpret the results. In fact, clinicians are much more naturally intuitive in statistics, I think, so in that sense. You know, it's almost like a little knowledge is a dangerous thing, but you know, yeah. I agree with your interpretation.
Yeah, I totally agree with the understanding. So the result is continuous, so not dichotomous. Because I am an emergency patient, so I every day see the patient. So it's like a gray scale, and the result is not 1 point. So yeah, your presentation is very interesting, and the discussion is very interesting for me. So it's very learning.
Yeah, I think at the moment what's happening is that lots of different people in lots of different places are looking at the results and trying to make, okay, what does this mean? And different people are coming up with different interpretations, and that's very natural. Some yeah.
Do you expect your results to change the guidelines for management of delivery?
Yeah, I mean, I think they will. They are doing so in the UK. People are not, I mean, there was some conversation with guideline people saying that the results, one of the people said that, this is a negative trial, and then I sort of objected to that use of language, but I mean, there's guidelines processes, and then there's clinicians themselves, and they're related to each other, but clinicians can do what they. I mean, I've had lots. Yeah, different people will be doing different things, but what I would like them to do is try and look at them all, take everything they know about the treatment and the condition, and try and synthesize it all, and not just dismiss it quickly. I think it's a lot of information. It's the biggest head injury trial ever conducted, and if we just sort of throw it away on the basis of the p-value for the primary endpoint, that would be a big waste, I think. More questions? No. In that case, thank you very much for sharing.